Now, as this is the gravitational potential energy of mass at infinity, if we will say let VE be the escape speed of body of mass m, so then that kinetic energy comes out to be what? 1 by 2 m into V square, because this gravitational potential energy which the body is having at infinity is at the cost of kinetic energy. So the body will escape from gravitation pull only if the kinetic energy of body is equal to the magnitude of potential energy at infinity. So how much kinetic energy is given to this very body, that will be that totally the total kinetic energy will be finally converted to the gravitational potential energy at infinity. Therefore this 1 by 2 m V square should be equal to what? That should be equal to, once we will take magnitude, it will be simply G m m over r. Or removing now this m and m will leave, then we will be having V square equal to 2 g m over r. Or you will be having, which implies VE equals to under root of 2 g m over r. This is one of the equation for escape velocity. But we can use one more thing. We also know in this equation we can use some different. We know that G equals to what? We know G is equal to Gm by r square. Instead of this very Gm, we can, which implies Gm equals to Gr square. Use instead of Gm in it Gr, then we will be having VE equals to under root of 2 into G into R square, because instead of Gm here we use Gr over R. This R and R will leave. It will be VE equals to under root of 2 G R. This is the equation for what? Escape velocity on the surface of Earth. And for Earth, if you will give value, then it comes out to be VE equals to what? It is 2 into G, that is 9.8, into R, that is 6.4 into 10 to the raised power 6. Once you are going to solve, it comes out to be 11.2 into 10 raised power 3 meter per second, and that is 11.2 kilometer per second. This is the value which you have to remember. And if you are going to talk about escape velocity on the surface of moon, escape velocity on moon, that will be again v escape, I will place it VEM equals to under root of 2 into the acceleration due to gravity, that is how much? That is simply 1.6 into the radius r, that is 1.75 into 10 raised power 6, and the value comes out to be how much? 2.37 kilometer per second. So this is the value of acceleration due to gravity on the surface of moon, and this is the value of acceleration due to gravity on the surface of earth. From these two values we can conclude that the more value of acceleration due to gravity is on earth because of the larger value of the g. Now we can here also calculate the escape velocity in terms of density of earth. As we know now, escape velocity ve equals to what? 2 g m over r raised to power 1 over 2. As earth is assumed to be a sphere of radius r and density rho, so we can say the mass of earth, that is m, equals to what? That is the volume of earth into density. So mass m is equal to, as it is taken as a spherical, then it will be 4 by 3 pi r cube, where r is the radius and rho will be the density. So if we will use this very value here, so what we get we get ve equals to, that will be like this condition, 2 g. Instead of m we will be having 4 over 3 pi r cube rho divided by r raised to power 1 over 2. Now 1 r is going to leave with this. It will be 4 2's 8. It will be like this. ve equals to, within the brackets, 8. It will be pi. It will be over 3 because that comes out to the denominator. Then it will be g r square rho, because 1 r is going to leave with this. G is here, r square will be here, rho will be here, 4 2, that's 8 in the denominator, raised to power 1 by 2. So g is constant, pi is constant, it will be 3. These terms up to this very value, they are constant. So ve is directly proportional to root of the density. So escape velocity on surface of Earth, a planet of high density, is more. So if a planet is, that is, if a planet is more dense, so escape velocity will be more on it, more on it. On the other hand, if we are having a planet on which density is low, so the escape velocity will be low. This is all for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.